Okay, welcome to Accelerated Math. This is imaginary numbers and the I facts. We're going to talk about simplifying powers of I. All right, so well, let's go back to what I is. If somebody asks you to do on the calculator the square root of -4, okay, some people would say, well, if you try that with a calculator, most calculators will give you an error and tell you that there's a domain error or an input error, and it's because of this negative right here. All right. Because if you think about a square root, well, let's go back to one that we can do. The square root of 4 is saying what number times itself will give you the value 4. Okay, so we know that it's 2 times 2 will give you this. Well, in the case of -4, some people might have thought, well, okay, what about -2 times -2? But when you do negative times negative, you get a positive, so it still comes out to +4. So that is not the square root of -4. The bottom line is that a negative cannot be square rooted, okay? And this became a problem. It's been a problem over centuries and centuries, and finally somebody decided that this was useful, and they kept pushing and pushing, and they decided that they were going to represent a negative with an I, okay? And let's take a look at it at square root of -16. What they just, whoops, sorry, tablet, -16. If what they would do is they would factor this out, and they would say, okay, that's the same thing as the square root of 16 times the square root of -1. And once they isolated this square root of -1, they would say, okay, that we are going to represent as an I. Okay, and then we can continue here. And of course, you know this is 4, but some people might show it as 4 times 4 and go down to prime numbers 2 times 2, 2 times 2, get all the way down to prime numbers, and then I like to say go fish. Find pairs. You find a pair of 2's, that gets out. You find another pair of 2's, that gets out. And when they get out of the radical sign or symbol, then they are multiplied on the outside. So 2 times 2 is 4, and we still have the I out there, so this means 4I. So this becomes the solution to the square root of -16. Okay, and so here's what I want to talk about is, let me clear that off. I to the first, we know it as the square root of -1. But anything raised to the first power is itself. Okay, we take a calculator and do 1,000,000 to the first power, it'll just come back and say 1,000,000. 57 to the first power is 57. So what we're going to say is that the I to the first, anytime we see that, that is the same thing as just plain I. So you don't have to show that exponent. I squared, of course, well, anything squared means itself times itself. So this is I times I. Now, think about it. I is the square root of -1. So we're saying the square root of 1, the square root of -1 times the square root of -1, that's what I squared is. Now, if you went to a calculator and you said square root of 8 times the square root of 8, you would get, well, you can do it, but you would get 8 as an answer. So anytime you multiply a square root by itself, effectively you're squaring it, and the squaring is undoing the radical symbol. So the square is the opposite of square rooting something, so it undoes it. All right, so then looking at this pattern, square root of 8 times square root of 8 gives you 8. What's the square root of -1? Right. Times the square root of -1, well, it's going to eliminate the radical symbol, and you're going to get -1. So here's what we're going to say is that the I squared value is the same as -1. Okay, so instead of I times I, we're going to say it's equal to -1. I to the third can be broken down. We're going to break it down this way. I to the third, we're going to break it down to I squared times I to the first, or just I. And we just said that I squared is -1, so this is -1. And we said that I to the first is the same thing as just writing plain I. -1 times I is just -I. And that's what we're going to say. Anytime we see I to the third, we're going to simplify it to I. Sorry, -I. That's what we just said. All right. Now, so let me clear these things and just rewrite this. I to the first was just plain I squared was I times I, and after we went through the simplification process, it came out to -1. I to the third came out to -I, and I to the fourth I to the fourth could be broken down, and let's break it down to I squared times I squared. What is I squared? I squared is the same as negative 1. And here we got another I squared, so that's negative 1. These are being multiplied. And what's negative 1 times negative 1? Voila, positive 1. That's the gold right there. That's, if you can get something simplified down to I to the fourth, you know it's the same thing as 1. Getting something down to 1 is pretty simple, and that's what we're talking about, is simplifying things. I to the fifth. If I wanted to say what I to the fifth was, I could say, well, it's I to the fifth breaks down to I to the fourth and I to the first. And I to the fourth, we just said, got down to 1. And then there's still the I to the first out there, or just plain I, and 1 times anything is itself, so I to the fifth is I. Now I'm not going to continue any further, as you can see, because what we've done is we're repeating a pattern. I to the fifth is the same thing as I to the first. Here, see it? I. So we're not going to show that. I to the sixth, you guessed it, would be negative 1. I to the seventh would be negative I. I to the eighth would be 1. Keep going up. 9, 10, 11, 12. Notice that the multiples of 4 are coming out to 1. This is the good one. All right, so let's put this to use. We said that I to the first is the same thing as I squared is the same thing as negative 1. I to the third is negative I, and I to the fourth, that was gold, that's 1, and we didn't care about I to the fifth because it's just a cycle and it continues. So these things, I refer to these as my I facts. They're facts that I need to know and helping me to simplify. I to the 13th. I'm going to break this down. I could break it down into I times I times I times I 13 times, right? But what I want to ask you is, well, how many sets of I to the fourth would be in this? Well, 1, if I had 2, that's I to the 8th. 3, that's I to the 12th. And there would be 1 left over. 1 I left over, okay? What did all these I to the fourths equal? Well, right here, they equaled 1. So that's like 1 times 1 times 1, because we have 3 of them, times there was an I to the first left over. Think about it. 13 divided into groups of 4 leaves you with a remainder of 1. All right, 1 times 1 times 1, of course, is 1. And then times I to the first, we said you don't have to say I to the first anymore, you just say I. So 1 times I is just plain I. So I to the 13th is I. All right, it's like I to the first. All right, now here's another way to look at this is you could say, well, how many times does 13 break into groups of 4? Well, 4 goes into 13 3 times, you multiply it out, you have a remainder of 1. That's what we're interested in. This one remainder was this lone I to the first sitting out here. And when you find out it's I to the first, you go to your IFACS chart and say, okay, that's I. Let's keep going with it. Again, our IFACS chart says that I to the first is the same thing as I squared is negative 1, I to the third is negative I, and I to the fourth is 1, and we said we didn't care about I to the fifth because it cycles over. I won. This is, I've heard some teachers say this, I won, and then you put the negatives in there. So they just, when they get their test, when they were students, they would write down I won, and put negatives in the middle, and that gave them their IFACS pattern. I to the first, second, third, and fourth, and then they could do this. So 26, we said we're going to break it into groups of I to the fourth and see what we have left over. How many groups am I going to find? Well, I'm going to have, 6 of them? 5, that's 20, 24, and how many left over? 25, 26. There had to be 2 left over. Now, I did it this way. You're not going to do that every time. You're just going to say 26. How many times is it divided into 4? I go, well, it goes 6 times. That's 24 with a remainder of 2. That's what I'm interested in, the remainder of 2. That tells you what you have left. I squared. The 2 from the remainder is going up here as my exponent. Then I just look at my list and I go, well, I squared is negative 1. So the answer to I to the 26 is negative 1. I hope this is working for you. Ooh, I to the 111 or 111th power. Ooh. So I definitely don't want to sit here and work out how many I to the fourth there are in there. I'm just going to go 111. How many times is it divisible into groups? How many times will it divide into groups of 4? So 4 goes into 1, it doesn't. 4 goes into 11, it goes twice. 2 times that is 8. I have 3 left over from that, and I dropped the 1 down. It almost went in 8 times, but it wasn't. It was 7. 7 times 4 is 28. I have a remainder of 3. And boy, we haven't worked with remainders in a long time, but we got a remainder of 3. I don't want to turn this into a decimal. I just want to know, okay, there are a bunch of I to the fourths, a whole bunch of them, in fact, 27 of them. Last thing I want to do is draw all those out. But then there was an I to the third left over. So this remainder tells me what the exponent is on what's left over. And that's all I'm interested in, is what's left over. I to the third according to my I facts chart. Remember, I1, doing slow motion, I1, I1. Okay, we're concerned about this one, and put your negatives in the middle. All right, so I to the third is negative I. I to the 111th power reduces down to negative I. Can you do it? Hey, if you do it with a calculator, like if you're not going to do this, and you take the calculator and do 111 divided by 4, you're going to get 27.75. So what you have to recognize is the decimal 0.75 represents a remainder of 3. A 0.5 on a calculator like that to come up to 27.5, then that 0.5 represents a remainder of what? 2, because think of it, it's out of 4, 2 out of 4. And a 0.25, these are the only decimals you're going to see when you do this with a calculator. If you end up with a 0.25, that's like a remainder of 1. So this one would be I to the first. A remainder of 2 is going to be I to the second, which is negative 1. And a remainder of 3, or 0.75, is going to be I to the third, which is negative I. All right, I think that's all I've got for you. All right, have fun reducing those powers of I.